Okay, let's go ahead and get going again. We've looked at how you can create special models in place that are very specific to a single project. And we looked at how you can take existing Revit component families and change them around, edit them to meet your needs. Now let's look at the third technique, which gives you the most power. That's how you actually go through and create your own new Revit component families that can be shared with everybody. And the idea is we want to create nice parametrically resizable forms that'll be very adaptable and reusable. Let's show you how that actually happens. Now, just to sort of demonstrate the technique, let's start by looking at how some of the existing families are already created, because we'll learn a little bit about how the basic technique or process goes. If I edit, for example, that couch family, you're used to looking at it in 3D, but let's look at how it's actually defined. There are a series of extrusions. That's an extrusion that kind of comes up from the ground up to some height for the height of the arms. This is another extrusion. It's going from left to right. And you might wonder where those extrusions start, where they stop, how that's all controlled. And if we go to the floor plan view, you'll actually see a little bit about that. In Revit families, there's usually a notion of a front to back center line. That's a reference plane. There's also a reference plane for left to right, and that is the intersection which determines how the object is inserted. So the insertion point is usually right at the intersection of the left, right, and front, left, right, and front, back centers. Okay. In addition to those, we tend to have reference planes which define the overall length of object and maybe the depth of the object. Okay. And we'll put parameters on those. We'll put parameters that move those reference planes and actually control the distance they're apart. And those parameters are the ones that actually appear in the properties that we can control. So when we change the properties, what we're actually doing is moving those reference planes. Now, we often have reference planes or dimensions and parameters that control the length. We'll often also include a dimension which ensures equality, which just keeps the object centered around the insertion point. So we'll also put some of those in. So the idea is we're going to go through and set up some reference planes that are going to control the length, the width, the height of an object. Okay, and then we're going to go through and start creating some forms like extrusions or sweeps or blends, things like that, that then are locked to those reference planes. And that's how they get resized. So let's go ahead and just take a look at how that would be applied in a brand new object. So for the purpose of the example, I'm going to go through and create a little pedestal table. It'll maybe have a squarish or rectangular top and maybe a round base to it. And we'll just sort of see about how we can go through and create that. The process of creating a new family always starts with, under the File menu, saying New, and you can choose to create a family. Then you get the choice of a template file, and there's different templates for different needs. Each of the different templates is associated with a different category in Revit. So if I want to put a piece of furniture in, I'll use the furniture template. Oh, if I want to put a plumbing fixture in or a window, I'll use that template. Notice that some of them are either floor-based, face-based, some of them are ceiling-based. If you choose one of those templates, there's a placeholder for a ceiling object or a wall object that the object would be placed up against. But for our purposes, let's just go ahead and create a generic one that can be placed anywhere. Okay, so we're going to go through and open the furniture template. Here's our brand new template. We're looking at it in the plan view, and you can sort of see there's the front to back center. And there's the left to right center. Again, this is going to be the insertion point right in the middle. So when we place the object, that'll be the center point. In the plan view, if I'm going to create a table, let's say a rectangular table, I'm going to give a width to it. I'll also give a depth to it, a height to it, things like that. And then maybe a radius of the base. So we'll set up some reference planes that are going to let us start controlling these different parameters. And we do that by choosing the reference plane tool. I'm going to put a reference plane at the back and at the front edge of the table, or what I envision being the table in the future. I'm going to put a reference plane over here on the left side of the table and the right side of the tabletop. Yeah, that's pretty good. We'll put one in the elevation view in just a little bit to go ahead and control the height, but this will get us started. So we have our reference planes. The next thing we need is a way to control the locations of those. And what we do is put dimensions on. So if I put an align dimension, a nice string dimension that goes between those three, I can turn on the equality constraint. That'll make sure that they always stay centered around the left, right, center. If I do it in this direction, I can turn on the equality constraint. Super. So now those dimensions will, or those reference planes will always be centered. If I move this one, the other one will move too. Okay, so we got our centering down. That part's looking good. Let's go ahead and add some annotations and some dimensions that'll let us control the length and the width, or the width and the depth. I always kind of confuse how I want to describe those things. Let's go ahead and I'll put a dimension in this direction. I'll also put a dimension in this direction. And if I want to associate a parameter with that, I will choose the dimension and then go to the label dimension and say create a parameter. And this is where I have the chance of actually creating a length dimension or length parameter that'll control that. So let me call this kind of the table length. Now with that, I can make it type or instance. I'm going to make it a type parameter, so I can have tables of different types for different lengths. Let me go through and control this guy over here. I'll make a new parameter over there. I will call it table depth. Make that a type parameter also. Now, before you go too far, it's always a good idea to do some flexing of these parameters. Just make sure the reference planes move the way you want them. So let's give that a try. I'm going to say, oh, table depth, and you can kind of keep these dialogues open together so you can kind of watch the effect. Just going to see if you can push it out of the way. The depth, let's make it 4 feet. That looks good. The length, let's make it 8 feet. That seems to be flexing. Let's make it 3 feet. Okay, so those seem to be flexing properly, so I think we're actually in pretty good shape. Okay, if we can move those reference planes properly, we are ready to start thinking about putting some forms in that then follow those reference planes. So here's the way that works. If you go to the create tool and we choose an extrusion, if I want that tabletop to basically be extruded kind of in the Z direction, what I can do is just draw some sort of form in here. Now you could draw it just right to the reference planes, but I'm going to keep it away from that because what I'm going to do is actually align and really lock to make sure that the edges of the boundary of that extrusion really are locked to the reference plane. That way they will always move with it. So I'm going to use the align tool to choose that boundary and lock to it. And you choose that reference plane and lock that boundary to it. I'm going to choose that reference plane and lock that boundary. And finally, this one. Super. Now we should actually be in pretty good shape when we finish that extrusion. The idea is you really want to make sure that if the reference planes move, that the boundary of the extrusion moves too, and it looks like it does. So we're feeling pretty good. Okay, that's pretty nice. Now if I look at this in 3D, you might notice it's a big old block that isn't very interesting. So let's go ahead and think about it in the elevation view and how we can actually control that. So I'm going to look at it maybe in the front elevation. Zoom to fit. There we go. You see that block's just sitting down on the floor. If I'd like to go through and give ourselves a little control over the height, what I need to do is create some more reference planes. So I'm going to create a reference plane that will represent the table height. I'm going to create another reference plane that will represent the table thickness, okay, just so we have a little control. So I can align, oops, let's go through and put the dimensions on first. Let's go through, I'll put a dimension from the reference level to the top. And again, it's totally up to you how you want to define the hierarchy of all these parameters. But I'll go through and say that's going to be table height. Now for the thickness of the table, I have a number of different ways I can do that. I could go ahead and define the bottom of the table, or the bottom of the tabletop, and put a dimension there. What I'm actually going to do is do it the other way. And again, this is where you have some control about the hierarchy of the dimensions. If I want to define it here and say that's the tabletop thickness, okay, that's another way of doing it. Super. Now watch out, if you put one more dimension, if I try to add a dimension here to here, okay, it'll report that. But if I try to add a parameter to it, it'll over-constrain things. You don't want to actually go through and put a second parameter in there because you can't have like all three of those be parametric. Two can, but one has to be floating as a degree of freedom. So we'll leave that as just those two. Oh, I should flex those just to make sure. Oh, let us say the tabletop thickness is only 4 inches. That looks good. The tabletop height is, let's say, 2'8". Looking pretty good. So if the reference planes are moving the way we want, we're ready to do some aligning. We're going to align the reference plane at the top. I'm going to align the reference plane to the bottom. Okay. And now we have our tabletop floating in space. So that's looking pretty good. Okay, let's go ahead and add just a few more pieces to this to kind of complete our example here. You know, we've created this one form, but you often make components out of several different forms. So let's think about if I want like a round base into this, I might extrude that up from the floor. So if I wanted to go through and create another extrusion that was going to represent the base, I could, for example, just draw something like that. Now, for that dimension, if I want to allow that I can control that, I might add a new parameter. Let me call it just a pedestal radius. Okay, we have the ability to control that now. Let me finish up that extrusion. Let's see how that actually works. Looking pretty good. Let's also look at it in the elevation view, just because we need to control that pedestal. Again, it's hanging down here at the bottom, that's fine. The top of that pedestal should be the bottom of the table, and we'll lock it to that. So we're doing pretty good. We can start thinking about adding all sort of interesting other parameters to this to kind of continue customizing it. For example, you probably want to go through and for this tabletop form, offer a material so we can add a parameter to that. We probably also want to add a material to that base. Okay. We could also start thinking about adding some other features. We could round off the corners. We could play all sorts of games. Let me add sort of a simple thing in there that'll just kind of be a little bit fun. Let's say, for example, we wanted to add a lazy Susan to this table. Some people like those, or like a turntable. Might be a better way to explain that. Not really sure where that name comes from. I'll just draw something up there. This is going to be kind of a circular thing at the top of the table that'll rotate around and kind of allow us to spin food around. I'll call this my turntable radius. Okay, now let's just go ahead and think about where that should be relative to the top and bottom. It shouldn't be down on the floor. It should sort of be up on the top. If you want it to sort of float above the top a little bit, you can do things like this. Let me add some more reference planes in here. Separate that just a little bit so you can see it better. Reference plane, I'm going to pop it over here. I'm going to put another one over here. If I add some more dimensions, for example, from the tabletop to, I'll have that be the bottom of the turntable. And then I'll have this part here be the thickness of the turntable. You can actually go through and control those. Let me choose this. If I make that 0, 1, for example, that dimension, since I don't have a parameter on it, should be honored all the time. Let me go through and make that like, 2 inches in there. So what I can do is take those two. I will align the top of the turntable to that. I will align the bottom of the turntable to that. Okay, so that should be floating around on top of it. Let's take a look at that. Oh, pardon my graphic. Kind of goober there. Okay, let's go ahead and see if that actually works though, because we might need to adjust it a little bit. Let's do some testing. If the table height is now 3'0", let's see if that turntable is going to move with it. Okay, it looks like it did. Or if it was 2'0". Looking good. Okay, so we have something that looks pretty customizable right now. Maybe to make this table even a little more flexible though, for that turntable, we can give a visibility parameter so you don't have to see it. You know, not everyone wants a turntable. So if we want to have a single table that has the option of having one or not, we can say again, turntable on or off. Okay, and now we'll have the ability to kind of turn that on or turn that off. So super. We have something looking pretty good. Let me save this away. Oh, how about we'll call this our table with turntable, just so we can recognize it. I'll load it into my project. Where is it? I believe it's right there. Super, I got my new table over here. Let's put it inside. We're by the kitchen. Then we'll look at it in 3D. Zoom out a little, there it is. Use a few tables and a few chairs around it. But if I now want to use that as my dining room table, I can start adjusting the parameters over here. So what do we have? Oh, let's go ahead and make that some sort of a wood tabletop. We'll go through and for the pedestal radius, oh, let's just go ahead and make this like a 6 foot by 4 foot table. About 2'6" feels right. The turntable's there. The pedestal, maybe I'll make that a little bit bigger so it doesn't feel like the table's ready to topple. And voila. Now that looks like it didn't quite get it in terms of the material. Let me just sort of see what's going on there. It should be there. Oh, it's just the appearance is not really doing anything. Let's go ahead and use the colored appearance. We're taking the appearance coloring to carry over. Looking good there. Again, we can turn on and off the turntable if we want to. As a parameter there. We're doing pretty good. Looks like I'm missing one parameter. Let me just go ahead and fix it, as long as we're in here, just so you have a complete example. Looks like the pedestal, the materiality there got lost somewhere. So again, I'll just reassociate it. Oh, looks like I maybe didn't put it in there. Okay, pedestal material. We can load that back into our project. So just using the cycle, you can kind of customize and tweak and ultimately get just exactly what you want for these new custom components. And the good news is because we've done them this way, put that in as wood also, you can share that. You can give that to me. We can put it on our class sharing website. You can post it on Revit City if you want to share that with other people. But that's where this huge collection of objects comes from. So go ahead and practice that. Get facile with that, and you'll be unstoppable in terms of being able to create just the components you need for your project.